Hello, I welcome you to this video where we want to discuss the concepts of vectors. So reading the question, it says, in the parallelogram OABC, vector OA equal to 4Q, vector OC equal to 6C, vector AP equal to 2/3 of AC, and M is the midpoint of BC. So this is the parallelogram that the question is referring to, with the two sets of parallel line in OC being parallel to AB and OA parallel to CB. Okay. Now, getting back to the other part of the question, it says find in terms of Q and or C, A, the vector AC. So how can we find the vector AC? Starting at A, ending at C, we want to find the alternate route that can be taken. Considering that in vectors, we always consider the direction as well as the size of the vector. So AC, alternatively, can be found by moving from A to O, then O to C. So we are saying the first part, and the diagram has been redrawn here for the sake of demonstration purposes. So we are saying AC, the vector AC is equal to AO plus the vector OC, okay? Where, as we move from A to O, we need to consider the direction. We are going against the direction where this magnitude is concerned. So we are going to say this is going to be negative 4Q under bar plus 6C under bar. So we've indicated the negative sign here because OA is going against the direction which has been indicated for the vector OA. So this is going to be the solution for the first part of the question. We can move our attention to the second part, which talks about the vector OP. How can we find the vector OP? So again, sorry about that. Again, we are going to say for part B, the vector OP equal to, starting at O, ending at P, the alternate route can be OA plus AP. Why AP? Because in the question here, we can see that AP has been given, so it is easy for us to take that route. So we are going to say OP is equal to vector OA plus the vector AP, which this part we are going to maintain OA plus AP, we are told is equal to 2/3 of AC. So we are going to put 2/3 vector AC. Okay. And then we can simplify what we have here. So this we are saying is equal to OA, we have 4Q under bar plus 2/3. Then AC, we've already found the position vector for AC, which is up here. So we are going to substitute. We have negative 4Q under bar plus 6C under bar. And then we can deal with the algebra here. So this is going to give us 4Q under bar, then positive 2/3 times negative 4Q under bar. This is going to give us negative 8/3 Q under bar, then 2/3 again times positive 6C under bar. This gives us the 3 can go into 6 2 times, so 2 times 2, we are going to have positive 4C under bar. Simplifying the like terms here, we are going to have 12Q under bar minus 8Q under bar over 3 plus 4C, which is going to give us 4/3 Q under bar plus 4C. So this is going to be the solution to the second part of the question, talking about the vector OP. So we can leave it at this, or we can factor out the 4 so that this now becomes 4 out. Inside we remain with 1/3 Q under bar plus C under bar. So either this or this is going to be the solution to this and this are the same actually. So that is for the second part. Moving our attention to the other part of the question, it talks about finding the vector OM. OM. So using this diagram here, we are saying OM, actually, M is the midpoint of BC. So it's supposed to be indicated here from the original diagram. So OM, starting at O, ending at M, we can take the root of OC plus CM. Okay, so we are saying for part C, the vector OM is equal to OC plus CM. OC plus CM. Understanding that CB or BC in terms of magnitude is the same as AO or OA. So CB actually is going to be half of CM is going to be half of CB. So that is why we've taken the root for CM. And simplifying this, we are going to say OC, as indicated in the question, is 6C. So we get that 6C underbar plus CM. So this CM we are saying is half of CB. And this vector has the same magnitude as what we have on the other side. So it is 4Q. Half of 4Q is what we are going to have for CM. Half of 4Q is going to be 2Q underbar. So this is going to be the solution to this part of the question at part C. Okay. Moving now our attention to the last part of the question. It says, hence or otherwise show that the points OP and M are collinear. So how can we show that the points are collinear? By collinear or collinearity of a vector simply means the vectors lie within the same line. So OP and M should be within the same line. And how do you show that the vectors are within, the points of OP and M are within the same line? So we can show by simply indicating if there is a scalar multiple for each of these vectors, let's say OP and PM. So what we are going to do in our case is this. So we are responding to the second part of the question, and we are saying to show that the vectors are within the same line, we are going to find the vector OP, okay? And then also compare it to the other vector, which is PM, okay? So we need to find these two vectors. So for OP, we understand that we've already dealt with it in the second part of our calculation. So OP, we have OP equal to 4 over 3 Q underbar, okay, plus 4C underbar, which we said is the same as, when we factor out the 4, it is the same as 4. Then inside we are going to have 1 over 3 Q underbar plus C underbar. So this is the vector OP. So now let's just find the vector PM and see if we can have a scalar multiple, if OP can be the scalar multiple of the other vector for PM. So PM, how can we find the vector PM? That is the question we need to consider. So PM can be found by moving from P to C, then C to M, okay? And that is what we are going to do. So we are saying PM is equal to PC, vector PC, plus CM, the vector CM. Okay. Do we have PC? Yes, we do have PC. So in the question here, we've been told to say AP is 2/3. So meaning we can divide these into two parts in terms of ratios. If this is 2/3 of AC, then this PC is going to be 1/3. Okay? Meaning the total is going to be 3 for AC. So this simply means PC is going to be 1/3, 1/3 of the distance or the vector AC plus CM, which we said is half of CB. I'm going to emphasize on that. So we said AP is 2/3, meaning the total here is 3. So meaning AP is going to be 2, then PC is going to be 1. So this is 2/3, then this is going to be 1/3 to make the complete vector for AC. That's why we've gotten PC is equal to 1/3 of the total vector AC. And then we substitute for CM. So from here, we are going to say this is going to be 1/3. For AC, let's get what we have for AC. Remember, we've already done the calculation for AC, and this is what we obtained. Okay, so we're going to get that and substitute into what we have here. So for AC, we have negative 4Q under bar plus 6C under bar, close, then plus CM. From the diagram, we can see that CM is half of CB, so it's going to be 2Q, this being equal to that. So we are going to have plus 2Q. We can simplify this. First of all, we are going to multiply the scalar with whatever is outside of the brackets. Sorry, with what is inside of the brackets. So we are saying this, it's going to be 1/3 times negative 4Q under bar. We are going to have negative 4/3Q under bar. Then 1/3 multiplied by 6C under bar. This is going to give us plus what? This is going to give us plus 2C under bar. Then we have plus 2Q under bar. So we can see that this and that one are like terms. We can put them together. So this is going to be negative 4/3Q under bar plus 2Q under bar plus 2C under bar. Okay, which when we simplify this part, we are going to have negative 4Q under bar plus 6Q under bar over 3, then plus 2C. So this fraction part is going to give us, we can see that negative 4Q under bar plus 6CQ under bar is going to give us 2, okay, over 3Q under bar plus 2CQ under bar. Okay, so this is going to be the solution to the vector PM. So this is going to be the solution to that vector. Now, when we look at this, again, we are saying it can also be written as the 2 is common, okay? If we factor it out, we are going to remain with 2 outside. Then inside, we are going to have 1/3Q under bar plus C under bar. So this is equal to what we have here. Now, when we compare these parts, let's look at these parts. The one from OP and the one from PM, which we have at the end of our calculation here. We can see that the inside part is the same, okay? Or in order for you to get OP, you can simply multiply this PM by a certain scalar, okay, which is 2 in this case. So because of that, we can conclude to say the points O, P, and M are collinear or are within the same straight line. So in concluding this part, for showing or indicating that these points are collinear, we are going to say, therefore, okay, the vectors OP and PM are multiples of each other. The vectors OP and PM are multiples of each other. Hence, they are in the same line. Or they are collinear. Okay, so this is how we show that the vectors are collinear. The points are collinear. You simply find the vectors connecting those points, and the solution is to show that if each of the vectors are scalar multiples of the other, then they are within the same line or they are collinear. So just for your own revision sake, you can take time to look at the solutions the way we've done it, part by part, and also share your understanding in the comment section. Okay? As you do so, you can also share, if you find this video to be helpful, you can share it to others so that they can also benefit just as you have also benefited from this video. And as you try out to express your understanding, you can get this question here and also give it a try in your own good time. Okay, so the concept still remains as we have done it from the question above. So you can pause the video, look at the question here, and test your understanding on vectors. Thank you. I'll see you in the next one.